I'm going to talk about Constrain, which is a system I built for creating animated figures on web pages. So the original intention was to write JavaScript code and get nice figures that I could put onto web pages. But as I developed it, I realized it could also be used to produce presentations using Reveal.js, which in fact is what we're seeing right now, and also to produce PDF diagrams that could be put into papers, so a possible alternative to things like ticks. So Constrain lets you write down a declarative description of the figure you want to produce, and then it generates the figure. The figure can actually have multiple frames, and in fact, these frames can even include animations. And the Constrain lets you integrate both graphical content and HTML content, and even have them interact with each other. So it has various pretty standard rendering capabilities. You can produce things like rectangles with text in them, and you can draw lines to connect things up, circles, and you can put in connectors between different objects. You can also put text inside of various objects, and it has a pretty good text layout algorithm. It's all constraint-based, so that means that the way that things appear can depend on the size of the window and other attributes like what fonts you have available. So here's a little bit of a sense of what the code for Constrain looks like. You can create multiple canvases on a web page, and you create a figure object to draw what's in the canvas. And then you can create objects that appear, like say a square, and you can use a kind of lightweight version of a builder pattern to attach attributes to those objects. To position the objects, you typically will introduce constraints. So these constraints are expressed in terms of variables. So every object comes with a bunch of variables that talk about things like where it's located, where its edges are, how big it is. And then you can write equations that relate those things. So here, for example, we're saying that the minimum y value of the square is twice the height of the square. Now, expressing all of your constraints with equations is a little bit awkward. So Constrain gives you a bunch of convenience methods for introducing these constraints. So the align method is extremely useful for this. Lets you align things on both the horizontal and vertical axes if you want. So here the green ellipse is being aligned to the yellow rectangle, and also its right edge is being aligned to the right edge of the canvas. So here are some examples of some things that you can do in Constrain. So I've used Constrain to produce course notes, and here's an example of some course notes using Constrain. You can see we have some little animations. We can see what happens when a function is called, and here are some data structure manipulations. So that's one thing we can do. Another thing that we can do is create geometric diagrams. So here's a little proof that the Pythagorean theorem holds, and you can see that it's actually interactive. We can drag this little diamond thing around and see different views. And when we get one we like, we can press the PDF button, and we'll actually get a PDF rendering exactly the way it looks. And here's a fancier geometry example where we're computing various points of inside a triangle and showing the circles that relate to them. And this is all being computed just by writing constraints that cause the right points to be computed. Constrain also has some support for automatic layout of graphs. And it's actually a pretty extensible system. So any kind of rendering you can do with JavaScript canvases, you can do inside of Constrain. And in fact, you can define your own kinds of graphical objects that do fancier rendering than what the basic things do. So the implementation of Constrain is all done in JavaScript. It's about 5,000 lines of code. And the way that it actually works is that when you introduce these constraints, cost functions are generated. And this is nice because if you have an over-constrained problem, things don't break badly. And you can also use costs to introduce optimization that is not sort of corresponds to a soft constraint. So then constraints are solved by minimizing cost. So cost minimization involves computing derivatives of the cost function, which is done with backpropagation. You might expect this then to be solved using gradient descent, but it turns out that's much too slow. So instead, Constrain uses a second order algorithm called BFGS. And one of the nice things about this is that when it's doing an animation, each time the time advances a little bit, it can solve the constraints starting from the last computed solution, and that's very fast. The other interesting algorithm is the text layout algorithm, which is a dynamic programming algorithm similar to what the tech system uses. So if you're interested in playing with Constrain, there is a reference guide that you can read with lots of examples. And there's a GitHub site where you can access the source code and any official releases. And of course, I'm always happy to get questions and suggestions. And hey, contributions are great too. Thanks.